Okay, who remembers what elasticity means? What does elasticity tell me? What piece of information does elasticity give me? Like, what is it measuring? You guys can look back in your notes if you need to. So not profit, Mikael, but revenue. And yeah, Yasmin, exactly. So it's a gauge of how consumers react when the price changes, and it's gauging that by determining what will happen to revenue if you increase or decrease the price. You got it, Emil. So okay, and we had three formulas for elasticity. Those formulas were eta is equal to P over X P prime, which is the same thing as Px prime over X, which is percent change quantity demanded, over percent change in price. Okay, and so what we just said is that this particular one you don't need to memorize because it's not going to be on your final, so you should just memorize the other one. And last class we did problems with both of them. We also said that sometimes you might need to use implicit differentiation. We're not going to do the implicit. I think that now that we know which one is there, and it's, you guys know how to do implicit, it also doesn't really add much to the subject. So we're just going to really focus on these two formulas today because either of these two formulas could show up. We didn't use that percent change one last time. So we're going to start with an example. What are we going to settle today, guys? Yes. Oh, we could have cupcakes or baguettes or rubber ducks. Oh my, so many options. I'm doing cupcakes because I really want one right now. So we have our demand function for vegan cupcakes. And the first thing that we want to do is find eta, our elasticity function, as a function of P. And so we said that the first step is to find either x prime or p prime accordingly. What am I going to be finding? Am I going to be finding x prime or p prime here? X prime, you got it. So I have x plus 2 is equal to 10 over p. And I could move that 2 over, but honestly, it really doesn't make a difference. I could also just kind of use implicit and go at it like this, where I recognize that my x is my function, so I have x prime plus 0 is equal to negative 10 over p squared. And this is just a derivative that we saw a lot with optimization. We remembered that derivative of 1 over x was equal to negative 1 over x squared. So x prime is equal to negative 10 over p squared. which brings us to our second step, which is to plug that in to the elasticity function. So elasticity is P times X prime over X. All right, guys, now I want you to tell me in the chat, what does this look like simplified? With the X and the P, but with no more complex fraction. So in other words, I don't want this complex fraction. That's not okay. So no complex fractions. What does it look like when I get rid of that complex fraction? In other words, that fraction inside of my fraction. Tell me in the chat what it's going to look like. Also, I don't want any negative exponents. And I don't want you to like, you can keep I want you to keep the X in your answer, just like what is the next thing that I'm gonna write when I get rid of that complex fraction and I don't have any negative exponents. So I've gotten 2 answers so far, neither of them has an X, so that's a little weird. Nope. So Emil, you still have the complex fraction there. But that's the closest I've seen. Not quite, Gwen. Nope. All right, okay, so it looks like we're having some algebra trouble. So let's think about this. There are really 2 ways that I could do that. Oh yes, almost, Mikael, except that you have a subtraction instead of a multiplication. So there are really 2 ways that I can think about this. I can do it in 2 steps. So I can say this p squared right here is a denominator. It's the denominator of my numerator, so I'm gonna move it down. And really I could think about this like by multiplying by p squared over p squared if I wanted, but I don't have to. I can just move that p squared down. So I'm going to move the p squared down, and I will end up with p times negative 10 over x times p squared. That p squared goes to my denominator. But then I see that I have a factor of p on top and a factor of p squared on top on bottom. This is not subtraction, it's multiplication on top. It's p times negative 10, not minus 10, which means that I actually can cancel those out. And what I end up with is negative 10 over xp. I figured it me. So you were good. You had it. Okay, so does that make sense what I did here? Now another thing that I could have done, just to get you guys like comfortable with thinking about algebra in different ways, and that way you have whatever way is the best way you do that. Here in the numerator, I have p times negative 10 over p squared, right? That's my numerator. And here I can actually cancel out one of those p's as well. So I would get that this equals to negative 10 over p all over x. But again, this p right here is moving down to my denominator. So this is negative 10 over px. And I end up with the same thing, just in a little bit of a different way. So what's important though is I want you guys to think about this. If I do it in the second way or even the first way, if I write, for example, negative 10 over p over x, then that's really confusing. I don't know what goes where, what's in the numerator, what's in the denominator. So notice how in green there, I wrote that numerator. This right here is supposed to be my whole numerator. That negative 10 over p. That is confusing. So instead, I write it like diagonally. And that shows me that's my numerator and that's my denominator, which makes it clear then that this p needs to go down. and not the x come up. Okay, are there any questions about the algebra that we just did right here? We'll call this an algebra break. Algebra break. Algebra is so fun, guys. Next, my third step is to rewrite this as a function of p. What does x equal? I want to replace that x with something in terms of p, so what does x equal? So if I go look, I know that x plus 2 is 10 over p, so x is equal to 10 over p minus 2. So that's what I'm replacing x with now. So I get eta is equal to negative 10 over x times p, which is negative 10 over 10 over p minus 2 times p. And then I'm going to distribute that p inside because I don't want to leave the complex fraction. So I end up with negative 10 over 10 minus 2p. And that is my eta as a function of p. Okay, are there any questions about how we just got this? Okay, so then B is we want to find eta when x equals 8. So in this case, in this problem, I'm given this x is equal to 8. But is eta a function of x or a function of p? It's a function of p. So I'm given x equals 8, but eta is in terms of p. So what that means is I need to find p. What p is associated with x equals 8? So I'm going to plug x equals 8 back into the original function to find the associated p value. So I know that x plus 2 is equal to 10 over p. So then I'm replacing that x with 8. So I get 8 plus 2 is equal to 10 over p. So I get 10 is equal to 10 over p, which means that p is equal to what? Is 10 over 100 equal to 10? There we go. P is equal to 1. So P is equal to 1. And so then I'm plugging that 1 in. Eta of 1 is equal to negative 10 over 10 minus 2 times 1, negative 10 over 8, which is negative 5 over 4. And is negative 5 over 4 less than negative 1 or bigger than negative 1? You got it. So this is less than negative 1. And if it's less than negative 1, is it elastic or inelastic? You guys can look in your notes from last time. You got it. It's elastic. So what should be done to price to increase revenue when it's elastic? You got it. So if it's elastic, so I want to decrease price to increase revenue. Okay, so this is all stuff that we did last class. Are there any questions about it?
I think it just doesn't make it really need.
Okay then. So in that case, we're gonna ask one more question that requires us to use that third formula that we haven't seen used yet. So here we'll say that if price is equal to $1 and decreases by 2%, what is the percentage change in quantity? No, it will be on the final, Yasmina. The one that won't be on the final is the other formula, the P over XP prime. So we used PX prime over X, and that's the formula you need to know for the final. So what we did will be on the final. And now we're using the third percentage formula, which could also be on the final. So it's only that first one that's not there. So if P is equal to $1 and increases by 2%, what is the percentage change in quantity demanded? Okay, so there are two main things in this problem. It says decreases by 2%. What is the percentage change in quantity? This question involves percentages, which is a clue that we should probably use the percentage formula. Okay, so our percentage formula is eta is equal to the percent change in quantity over the percent change in price. Do I know what the percent change in price is? I'm given that. So this is given. This percent change in quantity, this is what I want. But this eta right here I want to know what happens if I move away from P is equal to $1, which means that I need eta when P is equal to 1. So I use my other formula to calculate eta when P equals 1. So with these questions, it's always a combination of the two formulas. Except also, I already did that. This right here was done in B. So what was eta when P equals 1? -5/4. So I'm going to have -5/4 is equal to the thing that I want, the percent change in quantity, over, am I increasing the price or decreasing the price? I'm decreasing the price. So this is -2. Okay, so just a question before I finish this problem, and you guys might need to look back in your notes. When we have a situation that is elastic, when the price is elastic, do we expect consumers to react strongly or not strongly to a change in price? Strongly. So elastic, so we...
I don't think that love's completely off the table. Will you be there? Can I still walk?
Okay, so we expect consumers to react strongly to a change in price. So if I decrease the price by 2%, hang on, I would expect, therefore, for the quantity to change by more than this. So I expect the percentage change in quantity to be bigger than 2, right? Because my consumer is reacting strongly. So in other words, expect percent change quantity to be bigger than percent change price. Because this is consumers reacting strongly. So also, I'm decreasing my price. And if I'm decreasing my price, do I expect quantity to go up or down? You got it, Dean. I expect quantity to go up, which means that I'm expecting, before I even do this problem, for my percent change quantity to be positive, because it's going to increase, and it's going to be positive something bigger than 2. So just by using logic, I can recognize whether or not my answer actually makes sense. So if I now solve for my percent change quantity, I'm multiplying both sides by -2, and I get that the percent change quantity is equal to -5/4 times -2, which is equal to 5/2, which, guess what? Is it bigger than 2? 5/2, bigger than 2? Yes, it's actually 2.5. So it's positive and it's bigger than 2. Our consumers are reacting strongly. This answer makes sense. So this percentage change formula, more than anything, really gives me information about how consumers are going to react. So my final answer here is that we would expect quantity to increase by 2.5%. And that's my final answer. Okay, are there any questions about this problem? We're going to do one more problem. I forget what we were going to sell earlier. What else were we going to sell? I do like bread. Bread is good. We could do like painted rocks. No, I don't sell. I don't know. Oh, rubber ducks. That's right. Let's sell rubber ducks. I like rubber ducks. We said that earlier. Rubber ducklings. The first thing we're going to do, same as before, we're going to find Ada. Yes, Emil, let's sell nature. Grass, rocks, water, air. Yes, there we go, air, rain. The demand for snow. So we want to find, you guys, I'm passing my very first Christmas in Montreal ever this year. And I really hope it's going to snow. I've never had snow on Christmas before. So cross your fingers for snow for me. The demand for snow is high. Golden air. Yeah, we can have some golden air too. Louisiana. I have been in Louisiana for Christmas every year of my life. And it does not snow there. Yeah, I'm sure after Christmas I'll be tired of the snow, but like on Christmas Day it can be white and that would be good. Okay, so we want to find eta elasticity as a function of P. So step one, take the derivative. In this case, we have x equals to a function of P, so we're good. We're just like x prime is equal to 1/5 times negative 2p. X is my function, P is my variable. So then I go straight to plugging that in to my elasticity function. Have you guys memorized it yet? What is my elasticity function? No, that's okay. Px prime. Oh, there we go. Good job, Brandon, Yasmina, Marina. Look at you guys. Good job. So Px prime over x. So then I am plugging into that. So eta is equal to P times 1/5 times negative 2p over x, which is equal to negative 2p squared over that 5 can go down to the bottom and we have 5x down there. So this brings us to our step 3, where we replace x with the original function. So eta is equal to negative 2p squared over 5 times 1/5 times 225 minus p squared. And guess what? Those 5's cancel out, and this one is way easier to simplify than the other one was. We don't have any weird things going on. No like weird complex fractions left over to simplify. And now I have eta of P. Okay, any questions about how we just got that eta? Okay, so now the next question, we're gonna ask the same question that we've been asking. I'm just gonna ask it in a little bit of a different way. Instead of being like find elasticity and interpret, how else could I ask that question? So I might say, for example, if price is slightly lowered from $10, what's going to happen to revenue? Will revenue increase or decrease? Well, we know that the number of units will increase, but that doesn't mean that revenue will increase, right? So how do we determine what happens to revenue? We look at elasticity. So I know that by lowering the price, I'm going to increase my number of units, but that doesn't necessarily mean that revenue will increase. So look at elasticity to see what will happen to revenue. And where am I looking at elasticity? Right there. So in other words, this question is the same thing as saying, find elasticity at 10 and interpret. Which is what we've been asking before. So I'm going to find eta of 10. And in this case, I just have my 10, which means I'm plugging that into my eta function, negative 2p squared over 225 minus 10 squared. That is negative 200 over 125, negative 8 over 5. And is negative 8 over 5 less than negative 1 or greater than negative 1? Comparing to negative 1, you got it. This is less than negative 1. And since it's less than negative 1, is this elastic or inelastic? This is elastic. So if it's elastic, what should I do to increase, what should I do to increase revenue? You got it. So we want to decrease price to increase revenue. Okay, so here I'm told that the price is slightly lowered. That slightly is important. We're slightly decreasing the price. So in the end, you guys were right in the beginning, revenue will indeed increase. We're lowering the price, so revenue will increase. So we can conclude here that revenue will increase. So in other words, this is the same question, only now I'm finding eta of 8. I'm still saying slightly, so eta of 8 will tell me what happens. So eta of 8 here, we just plug in 8, so I have -2 times 8 squared over 225 minus 8 squared, so that's -2 times 64, that's -128. 225 minus 64, that is 161. You got it, Mikhail. It is greater than -1. And if it's greater than -1, is it elastic or inelastic? You got it. This is inelastic. So what should I do to price to increase revenue? Increase price to increase revenue. You got it. All the ins go together. Remember, inelastic, so increase price. Price to increase revenue. So if I lower my price, what's going to happen to revenue? You got it. So in this case, lowering my price will cause revenue will decrease. Are there any questions about these two questions? This is just another way that you could ask for elasticity without specifically saying, find elasticity. Okay, so if price is $8 and increases by 1%, how will quantity change? Okay, what formula do I need here? You got it. So I have 1%. So I'm going to be using my elasticity formula. So I have elasticity is equal to the percent change in quantity over the percent change in price. And that percentage formula, the fact that I have a percent there tells me to use that. Where am I going to be evaluating eta? At 8, you got it. We're told about 8. So I know that eta of 8. So just a question. Was it elastic or inelastic at $8? You got it. So my price was inelastic at $8. So with inelasticity, do we expect the consumer to react strongly or not? Not. So elastic is strongly, inelastic is like, not strongly. So inelastic, so as we set up here, elastic goes with strong reaction. Inelastic goes with not strong reaction. So we don't expect consumers to react strongly. So what this means is before I even start this problem, I can say that my expectation is that quantity will not change by as much as price. Since price is changing by 1%, I expect quantity to change by less than that. So I know that my eta of 8 was negative 128 over 161. So I have negative 128 over 161. And I have my percent change quantity here. And how much is price changing? Is it increasing or decreasing? It's up by 1%, which means that I'm going to have a +1 down here. So this tells me then that my percent change in quantity is actually just equal to elasticity, negative 128 over 161. So price going up, of course we would expect quantity to go down, and this is approximately 0.795. It is less than that one. So we would expect quantity to decrease by 0.795%. Did you guys learn, have you guys learned elasticity in your econ classes? No? Has anyone here learned elasticity in their econ class? No? You will. No one? In my other class, a few people had. Okay. Well, note that you will, and hopefully when you do, yeah, no, it's definitely too late for it now, but no, you will eventually. Like, yeah, I can't remember which econ you learned it in, but you will. I think in my other class only 4 people had, so like, you'll take econ in the future and you'll learn about elasticity, and hopefully it will make sense to you because you've already done it in math. So we have one last question to ask about this, and that is, how many units should be sold? How many, wait, what were we selling again? Rubber ducklings. How many rubber ducklings should be sold to maximize revenue? How do we maximize revenue inside of an elasticity question? So last class we saw that elasticity has 3 cases. So I could find my critical values and use the second derivative test, absolutely. Except I'm inside of an elasticity question and I already have my elasticity. So I don't have to do that here. I don't have to find my revenue function. I can just remember that eta equals to -1 is unit elasticity and occurs when revenue is maximized. So we did one like this last class as well. So when we're doing elasticity, it makes more sense to just use elasticity all the way through. So to maximize revenue here, I really just need to set eta equal to -1. So here, this is also saying set eta equal to -1. So my eta was -2p squared over 225 minus p squared, which I'm setting equal to -1. I multiply that over to get -2p squared is equal to -225 plus p squared. So -3p squared is equal to -225. And then I'm going to divide by -3. 5, 6, 7, 8, 9. 225 is divisible by 3. That's going to be 75. So I get p squared is equal to 75. Which means p is equal to plus or minus the square root of 75. What should I take, the plus or the minus? Taking a plus because it's a price, and so I'm not going to charge a negative value. So price is equal to the square root of 75, which is approximately 866. But I asked for my number of units. So I need to plug back in to the original function. To find units. So I'm going to have that x is equal, what was my original function? 1/5 times 225 minus the square root of 75 squared, which gives me 1/5 times 225 minus 75. That's 150. 1/5 times 150, which is 30. So to maximize revenue, we want to sell 30 rubber ducks at $8.66 per duck. And voila. So we maximized revenue here and got a very similar answer to our optimization questions, but we did it using elasticity. And you guys also have an example like this from your last class, as well. All right, y'all have any questions? Then guess what? I am officially done teaching you things. From now on, it's the mock test and then review until the end of the semester. You have learned everything you need to know for Cal 1. All right, then, let's